Bismillahirrahmanirrahim. Welcome to this topic, half-angle identities. The last part we spoke about the double angle identities, cosine to alpha, sine to alpha, and tangent to alpha. And in this part, I'm going to speak about the half-angle identities. Start with the sine alpha over 2. Sine alpha over 2 equal to plus or minus square root of 1 minus cosine alpha divided by 2. These half-angle identities can be induced from the double angle identities. But to start with this one, we have sine alpha over 2 half-angle identity equal to plus or minus square root of 1 minus cosine alpha over 2. This is plus or minus. Depend on the alpha over 2 in which quadrant is it, in the first, second, third, or fourth quadrant. So it is equal to plus or minus square root of 1 minus cosine alpha divided by 2. Cosine alpha over 2 equal to plus or minus square root of 1 plus cosine alpha divided by 2. So for the sine, we have 1 minus. For the cosine, it is 1 plus. You have to be careful about these signs. For the tangent, alpha over 2 is equal to plus or minus square root of 1 minus cosine over 1 plus cosine. Because we know that the tangent is sine divided by cosine. So if we divide sine by cosine, we'll have square root of 1 minus cosine alpha divided by 1 plus cosine alpha. Or it can be also equal to sine alpha divided by 1 plus cosine alpha, or it's equal to 1 minus cosine alpha divided by sine alpha. The other two identities can be induced from the first one by multiplying by the conjugate in the denominator or the numerator. If you multiply the denominator by the conjugate, I will have 1 minus cosine alpha over sine alpha. If you multiply the numerator by conjugate, we'll have sine alpha over 1 plus cosine alpha. And the choice of the plus or minus depends on the quadrant in which that alpha over 2 is given. Let's apply this for some exercises to find some trigonometric values and apply the half-angle identities. So in each one of these examples, use the half-angle identities to find the exact value of each trigonometric expression. First one, sine 75. In one of the lectures before, we found it, sine 75 by the sum between two angles. It is sine alpha plus beta, which is 30 plus 45. That will give me 75. But in this lecture, I'm going to use the half-angle identity. We know that 75 equal to 150 divided by 2. So I'm going to use this one, the half-angle identity. It is 150 divided by 2. So I can write sine 75 is equal to sine 150 divided by 2, which is equal to. Now 75 is in the first quadrant. This is in the first quadrant. So I will choose the positive sign because sine in the first quadrant is positive. So it is 1 minus cosine of 150 divided by 2. Using the half-angle identity, it is plus square root of 1 minus cosine 150 divided by 2. But now 150 is in the second quadrant. This is in the second quadrant. And the cosine in the second quadrant is negative. So this is the plus square root of 1 minus cosine of 150. We have to use the reference angle identity. So it is minus cosine of 30. Because in the second quadrant, the reference angle is 180 minus 150, which is equal to 30. So we are using the reference angle angle to find the value for cosine 150. This is equal to plus square root of 1 plus minus with minus will give me plus. Cosine of 30 is square root of 3 divided by 2. All divided by 2 of this and that's square root. Combine them together. I will have plus 2 plus square root of 3 divided by 4, or it can be written as 2 plus square root of 3 divided by 2. Multiply this by 2, and this is down, I will have 4. So the value for sine 75 equal to square root of 2 plus square root of 3 divided by 2. See question number 26. 26, we need to find cosine of 105. We know that 105 equal to 60 plus 45. This is if we need to use the sum of the two angles, and also we know it is equal to 210 divided by 2. And since the question says use the half angle identity, I will use the half angle identity. It is 210 divided by 2. I will not use the alpha plus beta because the question says use the half angle identity. So cosine of 105 is equal to, it is plus or minus square root of 1 plus cosine of alpha, in this case is 210 divided by 2. But 105 is in the second quadrant, and cosine in the second quadrant is negative, so we will choose the negative sign. So this is equal to minus square root of 1 plus cosine 210 divided by 2. And also 210 is in the third quadrant. Cosine in the third quadrant is negative. So this is equal to minus square root of 1 minus cosine. The reference angle for 210, reference angle theta prime equal to, in the third quadrant is theta minus 180, which is 210 minus 180 is equal to 30. So this will be 30. Reference angle is 30 and cosine is negative, that's why we put negative sign. It is minus cosine of 30 divided by 2. So I will have negative or minus square root of 1 minus square root or cosine of 30 is equal to square root of 3 divided by 2 or divided by 2, which can be written as minus 2 minus square root of 3 divided by 4 or it is equal to minus square root of 2 minus square root of 3 all divided by 2. So this is cosine of 105 and it is negative because 105 is in the second quadrant. Question number 27. We need to find tangent of 67.5. 27. We need to find tangent 67.5. But this is equal to tangent of 135 divided by 2. 67.5 equal to 135 divided by 2. So we use the half angle identity. And we have 3 forms for the trigonometric identities for the tangent alpha over 2. I can use a plus or minus the square root of 1 minus cosine over 1 plus cosine, or I can use sine divided by 1 plus cosine, or 1 minus cosine over sine. So I will use the form which is given by sine alpha divided by 1 plus cosine alpha. And alpha in this question is given to be 135. It is not 67.5, it is 135. This is alpha. This is alpha divided by 2. So it is sine of 135 divided by 1 plus cosine 135. Now, 135 is in the second quadrant. Sine is positive, cosine is negative. And the reference angle for this one equal to 180 minus 135 equal to 45. So this is the reference angle. So this is equal to sine of 45 divided by 1. Cosine in the second quadrant is negative, so this is minus cosine of 45, which is equal sine of 45 is the square root of 2 divided by 2 divided by 1 minus the square root of 2 divided by 2, which is equal to by 2 minus the square root of 2, or divided by 2. We can cancel this one with this one. So I will have the square root of 2 divided by 2 minus the square root of 2. So this is the tangent of 67.5. Can take one more. It's question number 30, 112.5, sine of 112.5. This is question number 30. Let's find sine 112.5. Sine 112.5 is equal to sine of 225 divided by 2. Again, because we need to find or we need to apply the half angle identity. And sine is equal to plus or minus square root of 1 minus cosine alpha, which is 225, or divided by 2. Now, 112 is in the second quadrant, and sine in the second quadrant is positive, so we'll take the positive sign. It is a plus. So this will be equal to plus square root of 1 minus cosine of 225. This is in the third quadrant, and the cosine is negative, so this is minus cosine. The reference angle is 45 divided by 2. So we will have a plus square root of 1 plus cosine of 45 square root of 2 divided by 2, or divided by 2, which is equal to plus 2 plus square root of 2, or divided by 4, or it is plus positive 2 plus square root of 2, all divided by 2. So this is the value of sine of 112.5 using the half angle identities.